in this problem, we are given this triangle with D here. The BD over DEC is a 1:1 ratio. And AF over FC is 1/2. Right? So we try to find out the shaded area, of course, in terms of ABC. Now, let's, for simplicity, assume the area of triangle ABC is equal to 1. Let's try to find out the area, the shaded area, right? That is GHED. Let's establish a few facts here. The big triangle minus the smaller triangle would be the shaded area. So this area equal to the area of triangle ADE minus the area triangle AGH. Now, for the ADE, that's going to be 1/2 of the ABC. Because why? Because DE over BC 1/2. This is from this ratio here, right? DE is just half of that. The ADE, we know that is half of the triangle ABC, which is 1/2. We know that this is 1/2. So what is this one then? For the AGH, let's mark it here. So in order to find this, it's good to find out the ratio. So what is AG over AD? So what is this ratio? And also what is AH over AE? So here a useful theorem, which is covered in my previous live video, that is Menelaus Theorem. Now in the theorem saying that if you have a straight line, in this case 9L, cutting triangle ABC with the point DEF here, this is DEF on the same line, and what we have is, in this theorem states that the AD over DB times BF over FC times CE over EA equal to 1. The trick here is, notice that you have A, B, C, and then the intersection point, D, F, E, right? D, F, E. So you go in the same direction. In this case, you go counterclockwise. A, and then you find D, B. B, you find the midpoint, which is F, and then from F to C, and then C to the midpoint, and then here, this ratio here, okay? Now, back to our problem. This triangle here, we try to find this ratio AG over AD, okay? So we're going to use this theorem here. The key of using this theorem is to figure out what is the triangle, which is the line that cutting the triangle. So first of all, we're going to look at this triangle here, ADC. Okay, we're going to use this line here. We're going to apply directly the triangle. So for the triangle ADC, apply minus AG over GD times D. Here, notice that the intersection of DC here is come to here B. Okay, so it's going to be DB over BC. So DB over BC times CF over FA equal to 1. We're given the condition here. Okay, so which means we're going to plug in the number. So this part, the final part, is CF over FA is going to be 2:1 ratio here. AG over GD is something we try to find. And then BD over BC, that's going to be 1/4. Okay, so it's going to be 1/4 equal to 1. So which means AG over GD is going to equal to 2. So which means AG over AD, the bigger part, right? So this is a 2:1 ratio, and this one AG would be 2/3 of the whole thing. Alright, this is the result. We're going to use it later. The other direction, we need to find AH over AE. We need to find that. How do we do that? So let's redraw this diagram here. Now this time we're going to look at the triangle ADE here. Triangle ADE here. Again, we're going to apply the Menelaus. So what we're going to have is we have AG over GD times DB over BE times EH over HA equal to 1. Alright? So AG over GD, earlier we know that this is 2/1. DB over BE, so it's going to be 1/3. 1/3. So this is EH over HA. So which means EH over HA is going to equal to 3/2. Okay? So which means we try to find what is AH over AE, right? So that's going to be 2/5. So 3/2 here is 3/2. Okay, so this is 2/5 of the whole thing. Now we try to find the shaded area. So we know that it's difference of ADE. So earlier we know that the area of AD is equal to 1/2. Now what is the area of AGH over AD? We claim that that's going to be the ratio of AG over AD times AH over AE. Now we know the two numbers here is 2/3, 2/5. So it's going to be 4/15. So the shaded area is equal 1/2 minus 4/15 times 1/2, right? That's going to be 11/30. Alright, so that's the answer. 11/30 is the shaded area. So in summary, what we did is we first figured out ADE, and then in order to find the shaded area, you need to find the smaller triangle. In order to find the smaller triangle area, you need to find the ratio of AG over AD and AH over HE, and we use Menelaus Theorem to find this ratio. Hope you enjoyed the video. Please like, share, and subscribe to the channel.